Hamna, Abdullah, are you there? Hamna, am I audible to you?
Yes, sir.
Okay, Hamna. So you were absent. So basically, we were studying about the formation of images by concave mirror, in which we have completed two parts. Object at infinity, then image is formed at focus, real and inverted, highly diminished, that means very, very small, and object beyond C, then image formation between image formed between center of curvature and focus, and in this case also real and inverted and smaller than object. You can see this is the object and this is the image size. So image is smaller than the object size when object placed beyond C. Abdullah, are you there?
Yes, sir. Sir, I bought it.
Okay. Now the third case comes here. Third case is object at C. Object at C.
You did
So
1 and 2.
Yes, yes.
Object at
Object at
infinity.
infinity and beyond object beyond C. Now we are going to do object at C. So this is our concave mirror, in which we have a principal axis, in which this is pole, this is focus, this is center of curvature, and we took object at C. That means this is the object at C. Now we are going to draw an image, and to draw an image, minimum 2 rays are required. So one of the ray will go parallel to the principal axis, and if the ray will go parallel to the principal axis, then it will pass through focus. This is the first rule. And a ray will pass through focus, then it will be parallel to principal axis. So I'm going to just extend it. So basically, the image, whenever an object is placed at C, image formed at C, image formed at C. And you can see this is real and inverted. This is real and inverted. Also, the third part, we can see same size, same size. Basically, object and image size are equal in this case. So a question can be asked, where should an object be placed in case of concave mirror so that the image size will be equal to object size? This is the only case in which the object size and image size are equal in a spherical mirror, that is concave mirror. Is that clear, everyone?
Again, sir, again.
This is the only case in concave mirror in which image size is equal to object size, or object size equals to image size. Got it?
Yes, sir.
Very good. So please write it and let me know.
Sir?
Please do it and let me know when you are done with this.
Sir? Sir?
Yes, yes, Abdullah.
Sir, will this chapter finish today?
This chapter means basically we can only finish up to mirror formula.
So, like refraction will be there. Means like, can we finish the refraction?
No, we cannot. Part will be finished most probably. Reflection, not refraction. What is the problem?
Because sir, day after tomorrow it's my English science test.
Day after tomorrow, that means on Wednesday, right?
Yes, sir.
Abdullah.
Yes, sir.
Day
Yes,
after
sir.
tomorrow means Wednesday, right?
Yes, Wednesday, Wednesday.
Okay, let's finish this. Okay, okay. We can complete up to reflection part. Reflection was in your syllabus, right?
Yes,
Not
only
refraction.
yes, not refraction.
Okay. So the fourth case come object between C and F. Object between C and F. That means center of curvature and focus. Are you done with this one, everyone?
Yes,
Hamna
yes,
and Abdullah.
yes, yes.
Hamna, are you done?
Yes, sir.
Okay. Now see object between C and F. Now you can see this is the concave mirror. We have a principal axis. This is principal axis. This is pole. This is focus, and this is center of curvature. And the object is in between center of curvature and focus. So the object is here. Now, parallel to the principal axis, one of the ray will go and pass through focus. And pass through focus. Wait a minute. This is the object. Like this, it will go and pass through focus. And one of the ray will go like this, pass through focus, and it will go parallel to principal axis, and the image formed will beyond C. So I can write image formed beyond C, and you can see that rays are actually cutting each other. That means real, and since it is opposite, so real and inverted. And you can also see that this is the object size and this is the image size. So image is larger than object. Image is larger than object, or image size is larger than object size. So this is the fourth case. And then fifth comes object at focus. Object at focus. Please do it, and if you have any doubt in this fourth case, let me know. Everyone done with the fourth one?
Yes, sir.
Abdullah.
Yes, sir. Yes, sir.
Now see object at focus. Whenever object is at focus, see where the image will form. This is pole, this is focus, and this is center of curvature, and the object is at focus. So one of the rays will go parallel to the principal axis, and it will be like this, pass through focus. And one of the rays will go like this. This is concave mirror. And the rays will go and retrace its path on the same. As I told you, whenever a ray will go through center of curvature, it will strike mirror at 90 degree and it will retrace its path. So basically, you can understand is like that. It will retrace its path. It will come back. And the image you can see, it is both are parallel and it will go at infinity. So the image formed at infinity, and in the second case we can take real and inverted, and in the third case image size are larger than or enlarged, we can see image size is larger than object size. So basically we take or suppose it like it will meet at infinity, and you can see that it is going far away from the principal axis. It will go so it will be far away from principal axis, so it will be larger in size. That's why image size is larger than object size, or in NCERT it will be written like enlarged. Image will be enlarged. Please let me know when you are done with this. And the sixth is object between focus and pole. Please let me know when you are done with the fifth case.
We're done.
Hamna,
Yes, sir.
okay, are you done with this, Hamna? Hamna, are you done with this?
Yes, sir.
Okay. Now see, object between focus and pole. So basically you can see this is a concave mirror in which we have pole, focus, and center of curvature, and the object is between focus and pole. Now see how the rays will go, and one of the ray will we will take it as the ray is passing through center of curvature. Whenever a ray passing through center of curvature and strike the mirror, it will retrace its path. It will retrace its path. It will retrace its path, and one of the ray will go like this. Now you can see this is basically parallel, this line, and these are not parallel. So basically we will extend it, and the rays will appear to meet behind the mirror. So the image will form behind the mirror. So we can write image formed behind mirror. Or you can see actually the image is formed by the rays appearing to meet. So image is virtual and it is straight, that means virtual and erect. And the third is basically image size is larger than object size. You can see it. Image size is larger than object size. Object size. It is also known as basically enlarged image. Please write it and let me know.
Sir, finished.
Hamna, are you done with this? Hamna, you are not audible. Are you done with this?
Yes, sir.
Okay. So see, it is very easy to understand. See, a concave mirror here is a concave mirror. When the object at infinity, see, object at infinity, image will be at focus, image at focus. This is the way to learn it. Object at infinity, image at focus. Again, object at focus. If object at focus, then image at infinity, image at infinity. Can you connect it? When object at infinity, image will be at focus. When object at focus, image will be at infinity. Now, the third case you can see, object beyond C, object beyond C, image, image between C, image between C and F, image between C and F. Fourth case, object between C and F, object between C and F, image beyond C, image beyond C. Are you getting my point, Abdullah?
Yes, sir.
It
Yes,
will be
sir.
opposite. You can see object at infinity, image will be at focus. Object at focus, image will be at infinity. Object beyond C, image between C and F. Object between C and F, image beyond C. Now see the fifth case. Object at C, object at C, image at C. Image will be formed at C. And the sixth case, which is very important. In case of concave mirror, only one case is there where virtual and direct images formed, that is object between P and F, and image behind mirror. In this case only virtual and erect. In this case only virtual and erect. And except this case, all the cases are basically real and inverted. Question can be asked in any way, like in case we are placing object at between C and F, the size of image will be larger, smaller, or anything. In case of this, it will be larger. If you will draw all the diagrams or the formation of images and you will look at it, it will be easily understood and you can remember it. Okay, Hamna? Okay, moving to the next part, that is it can be so when we talk about the uses of concave mirrors, so basically these are, that means mirror are commonly used in torch and also vehicle headlights to get powerful parallel beam of light, to get powerful parallel beam of light. Also used by dentist also used it, so that teeth will have a larger image. And also used Abdullah and Hamna, am I audible to you?
Yes, yes, sir.
Is the screen shared?
Yes, sir.
Okay. Also used in solar furnaces to concentrate sunlight to produce heat. So it is very easy and It can be asked, write 3 uses of concave mirror. So basically concave mirror are commonly used in torches, searchlight, and also vehicle headlights to get powerful parallel beam of light. Parallel beam of light also used by dentists and also used in solar furnace to concentrate sunlight to produce heat and give energy to solar furnace. This is the uses. Then we are going to talk about the image formation by convex mirror. There will be only 2 cases, at infinity or in front of the mirror, convex mirror, and then we will go for mirror formula. That is very easy.
Sir,
Let me
finished.
know when you. Yes, Abdullah,
Finished.
you are not audible.
Sir, finished.
Finished. Very good. Amna, are you done with this?
Yes, sir.
Very good. Very good. Now see, image formation by convex mirror. By convex mirror. When we talk about image formation by convex mirror, so first of all, object at infinity. See, this is the convex mirror. The curved part is polished. And this is basically principal axis in which this is pole, this is focus, this is center of picture. I told you that whenever object is at infinity, image or rays will come parallel to the principal axis. The rays will be parallel to principal axis, so it will reflect in the same way. It will also reflect back, and it will appear to meet at focus. It will appear to meet at focus. So I'm going to write image formed at focus. Image formed at focus. Highly diminished. That means very small size. Highly diminished. Diminished. That means the size is point sized. Point sized. And the third one is basically you can see the image is formed by the rays appears to meet. So basically virtual and erect. Virtual and erect. See, there are only 2 cases since in convex mirror, the focus center of curvature is basically behind the mirror. So basically that's why it has only 2 cases, object at infinity, and the second case, object between infinity and pole. Between infinity and pole of the mirror. Pole of the mirror. Please do this and let me know. Then we are going for the second.
Sir, finished.
Are you done, Hamna? Hamna, are you done with this?
Yes, sir.
Very good. Now see, this is a convex mirror. And this is basically our principal axis in which this is pole, this is focus, and this is center of curvature. And the object is present between pole and focus. So the first image will go like this and it will reflect back. And the second will try to go at center of curvature and it will reflect back. So when you are going to extend it, the image will form behind the mirror like this. So I'm going to write image formed between pole and focus. Pole and focus behind mirror. You have to remember it that in case of convex, focus and center of curvature are behind the mirror. And also diminished, that means a small image. And the fourth one, virtual and erect. Virtual and erect. So basically, in case of convex mirror, all the images will be formed by all the images formed by convex mirror are virtual and erect. In case of concave mirror, there are 6 cases in which one of the cases will form virtual and erect, and all the rest 5 cases, in rest 5 cases, the images will be real and inverted. Is that clear?
Yes, sir.
Very good. Please write it. And then we are uses of convex mirror. So convex mirror are used as a rear view mirror. See, in our bike or car, we have rear view mirror in which big truck, buses, cars, and bicycle or motor car you can see basically its images, small images. So the convex mirrors commonly used as rear view mirrors. Also, they have a wider field of view. They have a wider field of view. A small convex mirror can capture a big, large, whatever is behind it, in front of it, it will capture it. So please write it down.
Sir, finish.
Finish. Very good. Now the next part comes sign convention, and sign convention is very easy to understand. If you will get it, it will be very easy for you to do the numerical. See sign convention. Are you aware of coordinate sign convention? Are you aware of x-axis, y-axis?
Yes.
You know that, Abdullah, you know that this is positive part, this is negative part, yes or no? This is
Yes.
positive part, this is negative part, yes or no? And this is basically origin. This is basically origin. Are you getting my point?
Yes, sir.
Now see, if you are going to have a concave mirror, this will be like this. And object will be placed in front of the mirror or behind the mirror. Tell me. For the formation of image, object will be placed in front of mirror or behind the mirror.
In front.
Front of the mirror. So the object distance will be always negative. Object will placed in front of the mirror. That's why object distance that we denote it or symbolize it by U will be always negative. And image distance, that depends where it forms. If image distance, if image formed in front of the mirror, it will be negative, and if it forms behind the mirror, it will be positive. Are you getting my point?
Yes, sir.
And you know that focus is in front of mirror. Focus of concave mirror is in front of mirror. So focal length of concave mirror will be negative or not, because focus is in front of. So this distance will be negative because it is on the left hand side of the origin. Are you getting my point?
Yes, sir. Yes, sir.
Now come to the next point, which is convex mirrors. So just suppose this is our convex mirror, and you know that in case of convex mirror, focus is on the right hand side. Yes or no? So this distance,
sir.
basically focal length, this is basically focal length of convex mirror is positive. Yes or no?
Yes, sir.
It will be positive because in case of convex mirror, you can see Focal length is on the right, focus is on the right hand side, and in case of this is on the left hand side. Are you getting my point?
Yes, sir.
So this is the basically, and you know that generally we take erect object, uh, a straight object, so it will be positive and the image will be negative if it is downward. Okay.
Okay, sir.
Now we are going to that is mirror formula. Mirror formula. Mirror formula. Do you know what it is? Mirror formula is the mathematical relation between image distance, object distance, and focal length. This is the mirror formula. V is image distance. Object distance will be always negative because it will be placed in front of the mirror. U will be object distance, and F is focal length. Focal length of a concave mirror will be negative, and focal length of a convex mirror is positive. Now going for magnification. Magnification. So basically magnification is, it gives the relative size of image with respect to object. How much image is larger or smaller, that is given by magnification. So I am going to define it. Magnification. Magnification produced by relative extent the relative extent to which the image of an object is magnified with respect to WR. Abdullah, is the screen shared? Is the screen shared?
Yes, sir.
Is your screen shared? Can you see the screen?
Yes, sir. Yes, sir.
So basically what I was telling you is that magnification is the uh, magnification produced by a spherical mirror. It tells about the image size. Image size, how much larger or smaller than the object size. And magnification can be written as magnification, that is denoted by M. M is equal to height of image upon height of object. Height of object. This is the formula of magnification. HI, that is height of image, and HO, that is height of object. Here is how we are going to calculate magnification. And there is another formula of magnification. Magnification is equal to height of image upon height of object will be equal to minus V upon U. And this V is image distance. Image distance. And this U is object distance. Object distance. Please write. Then I will give you some question.
Sir, this is the last topic.
Yes, what you just said.
Topic.
This is height of image and height of object.
This is the last topic. After this is
Yes, yes, yes. This is the last topic.
Okay, sir.
Yes. Are you done with this?
Yes, yes, sir.
Okay, I'm going to give you a question that can be asked in your. A convex mirror used for rear view. A convex mirror is used for rear view on an automobile has a radius of curvature 3 meter. Has a radius of curvature 3 meter. If a bus is located at 5 meter from this mirror, find the position, that means image distance, find the position, nature and size of the image. Let me know if you don't know how to solve it. Can you solve it?
Sir, I got 8 by 15.
You got
8 by 15.
what you just said about image distance, what you have calculated.
I did 1 divided by V plus 1 divided by U.
No. What I'm trying to ask you is that what you just calculated, what you have find out.
And the position of the bus.
Okay, see. First of all, radius of curvature is given 3 meter, and since it is convex mirror, so the focal length is basically r by 2 in case of both concave or convex, and since it is convex, so it will be positive. So we got 3 by 2 meter focal length. Again, object distance u will be 5 meter. Yes or no? Negative, because it will be kept in front of the mirror, and we are going to calculate v. So 1 by v plus 1 by u is equal to 1 by f. Now 1 by v is equal plus 1 by u. 1 by u, that means minus 5, is equal to 1 by f, that means 3 by 2. Again, we are going to solve it. 1 by v upon 1 by 5 will be equal to 2 by 3. Again, 1 by v will be equal to 2 by 3 plus 1 by 5. And 3 5s are 15, 3 5s are 2 5s are 10, 5 3s are, so it will be like this, 1 by 5. 1 by V is equal to 13 by 15. 13 by 15. This is the value of 1 by V. So image distance V will be 15 by 3. And since it is positive, 15 by 13, since it is positive, that means image formed is behind the mirror. Behind the mirror. So you can solve it and it will be 1.15 meter. 1.15 meter. This is the position of the image. Position of the image. Nature is basically behind the mirror. Image formed, since it is positive, image formed behind mirror, and also virtual and erect. Virtual and erect. Image formation by convex mirrors is always virtual and erect. Now size of image, m is equal to height of image upon height of object. That is not given, so we will use minus v upon u. So you can see magnification. Does size of the image given? Center of curvature, this is this. Okay, magnification will be equal to minus, and v as a value 1.15 and u has a value that is minus 5. So you can solve it and it will be negative, negative, positive. M is basically positive, and in positive it is basically 0.15 divided by 5, that is 0.23. So basically this positive sign tells us that it is virtual and erect. Okay.
Yes, sir.
Okay, please note it down. It is very important.